Backend interviewers use the security round to see if you understand the risks inherent in the code you write. They are looking for a defensive mindset that anticipates how an application might be exploited. This starts with the distinction between authentication and authorization. Authentication is the process of verifying a user's identity, answering the question, "Who are you?" Authorization happens after they are logged in, determining which specific resources or data that specific identity is permitted to access. Plain-text passwords are a direct liability. If a database is compromised, every user account is immediately exposed. In an interview, failing to recognize this risk suggests a lack of basic security awareness. BCrypt solves this by passing the password through a one-way hashing function. We inject a salt, a random string of data, before hashing. This ensures that even if two users have the same password, their stored hashes will be unique, making the database useless to an attacker trying to reverse the process. When you can clearly separate identity from permissions and explain the mechanics of hashing, you demonstrate the baseline architectural awareness required for backend roles. In Spring Boot, the logic that protects your application is organized into the security filter chain. Every HTTP request is intercepted by the filter chain before reaching your controllers. These sequential checkpoints scan for credentials, like a JSON web token, confirming the user's identity. If invalid, the filter rejects it with a 401 unauthorized status, stopping it instantly. It is a common mistake to rely on the front end to secure an application by hiding buttons or links. Because anyone can send a request directly to your API using tools like Postman or curl, the backend filter chain remains your only reliable line of defense. Beyond login logic, you must defend against injection and session hijacking. XSS involves malicious scripts being saved into your database and served to other users, while CSRF tricks a user's browser into performing actions on a site where they are already logged in. Look at this Spring Boot GET request. It uses an ID from the URL to fetch an invoice from the database. Find the flaw. If a user changes the number in their browser from 5 to 6, what prevents them from seeing someone else's data? This is a broken access control bug. The system never checks if the authenticated user actually owns the invoice. This is an insecure direct object reference, or IDOR. To fix this, we add validation to compare the user's session ID against the invoice's owner ID. This IDOR example shows why we cannot trust the data arriving in a URL. Every request must be treated as potentially manipulated until the backend verifies the user's relationship to that specific resource. To handle this at scale, we use role-based access control. By following the principle of least privilege, we ensure users are only granted the minimum level of access required for their specific role, reducing the impact if an account is ever compromised. We also implement rate limiting. Since BCrypt hashing is intentionally resource-intensive to prevent brute force attacks, limiting how many times an IP can attempt to log in protects the server from being overwhelmed. When preparing for your interview, use this checklist. Start with the basics. Always hash passwords with BCrypt and sanitize user inputs to prevent XSS. Next, verify resource ownership to block IDOR and use roles to manage permissions. Which of these vulnerabilities do you find the most difficult to account for in a large project? Share your thoughts in the comments. And remember, never commit your API keys or secrets to version control.